Okay, today we'll be using Kangaroo in Grasshopper, which is a physics-based simulation plugin. It comes with Grasshopper if you got it in like the past 5 years. So I'm assuming everyone has it. Today we're going to use it to simulate a roof structure and a bridge structure. And if we have time, we'll look at something wearable. But I thought it'd be nice to do this more in a structural sense today. For looking at more of what Kangaroo can do. In the past, we kind of just played around with it looks nice, but today this might be actually useful, so we'll see. So when this pulls up, does anyone know about the, I don't know how to say it in English well, the guy's name. There's a bridge that's like a draped piece of fabric that creates a bridge structure. Let me pull it up. I think I typed it in right. Yeah. Yeah, there's a nice one. Has anyone seen this bridge before? Okay. Yeah. It's a fun one. Talking about like a physics-based simulation, we can do a lot of kind of structural analysis with it. Not technically, but kind of. If you know about the Sagrada Familia like building and how that was designed, it was designed basically with strings and weights upside down to get all the arches correct. Very similar for this. If I can find a picture of the design of it. Yeah, here's a good one. Where it was just a cloth tied down to certain positions in this box, and then you get this like minimum curvature surface between all these points. With a fabric. So we can do this and simulate it just like they did it physically many, many years ago. We can do this digitally in Grasshopper, but the method is very similar. So let me pull it up so we can look at it. Okay, so that's what we'll be getting to today, at least with the bridge one. I have 3 different workflows that aren't too long, so we'll see what we have time to go and do today.
Quick question.
Yeah.
And so I know that AI can write computer code.
Yeah.
Can AI write Grasshopper code?
Yeah, it's a good question. It kind of can. It's not the best. But if you're interested in it, like I have a Grasshopper Python script that connects to the open AI like API for going to ChatGPT. So if you want to do ChatGPT in Grasshopper, you could. It's kind of
describe it.
Yeah, it's kind of weird. Like you can ask it to write code because in Grasshopper we can write straight C# or straight Python. So in that sense, you can ask it to write it and it does pretty well. But there's not a good way to ask it to do the block structure like in Grasshopper. It can describe what steps to take, but since it can't just type in blocks, it's a little difficult. But it is an interesting field that people have been like looking into how to do it. But yeah, if you're interested in it, we could look at it one of these days where it's like a just a workflow session and not a workflow thing. But yeah, it'd be cool. Okay, so that's one. The other thing we'll look at, which they're very similar methods that get very different things, but kind of this pavilion structure as well. So we'll build these all in Kangaroo today. But a quick overview of Kangaroo. Let me pull up the plugin. So the most important thing in the Kangaroo plugin is going to be the solver, which this is the thing that does all the iterations for the physics. There's a couple different solvers you can use. There's the standard solver. There's also a step solver, so you can do iteration by iteration. You have more like granular control over that. We have a zombie solver that it shows you the final output at the very end, whereas this one we can see like it actually moving. The zombie solver will just show you the final frame. And then the one I like to use is the bouncy solver. So this adds momentum into it. I don't know, it kind of looks fun as it bounces up and down, but you know, up to you. There's a lot of different solvers for different applications. So going off the solver, that's like the main hub of everything, but there's a lot more going on in here, and most of them are going to be goal conditions. So telling the solver what you want to get to and how you want to constrain the simulation. So this first one, we've given it gravity first, so it can come off the XY plane. And then we've also restrained it with edge length, so the edges of the mesh can't get longer or shorter than like 0.7, so there's like an ideal to get to. And then the last one here, just the anchor, we've restrained all these points onto the XY plane so they don't move. So with all that working together, you can get some interesting physics movement with that. So we'll open up a new file and just start building that, and we'll walk through it. Okay. Okay, so in Grasshopper, the first thing we can do, we're going to start with that pavilion one. And just move over here. With the pavilion, I thought it was nice that you could put in any curve on the XY plane and then generate a pavilion off of that. So the inputs were very simple. So to work like that, the first thing that we can do is draw a curve on the XY plane. And then that curve will be the basis of the mesh that we will then use to create this pavilion structure. So you can create any kind of curve you want. The one I had was kind of L-shaped, but up to you what you think is interesting for this. Okay, does everyone remember how to draw the curve, basically? Nice. It'll be important to close the curve off as well. So reconnect the last point back to the first point, just so we get a whole closed loop. If we don't do that, the next couple steps won't work correctly. So. Okay, everyone got a curve down? Easy enough. Cool. Does anyone remember the next step of like how to get a curve into Grasshopper so we can use it? Yeah, you just type curve? Yeah, basically, yeah, pretty easy. For anything, we'll just use the black hexagon icons. So if we want to put in a curve, put in a curve. A polyline is also a curve. So if you drew like a segmented line section thing, that'd also be a curve. You also remember how to put the curve into this curve component?
They send multiple curves.
Yeah. If you right click it, it depends if you have one or multiple, but either would work in this sense.
To the points, the several points we should do multiple curves, or is that all of that just one curve?
It's a good question. Yeah, when you're using the curve tool, like if I was to use the curve tool, once I start drawing to when I stop drawing, that's one curve. If I was to come back and do it again, it'd be a second one. But as long as the curve is made up of just one command and then you stop, that's one curve.
Okay.
Yeah. So we can set one curve and then just click on that curve. And then once you did it correctly, it should show up as green when you click on it in Grasshopper. So to create a mesh from this curve, we'll want to fill in the inside of the curve with some geometry. So the easiest way to ever do that with a 2D curve is to use a component called patch. And this will take any boundary curve and just fill it in with a surface. So the patch component has a lot of inputs here. The only one we care about though is going to be the curve to patch. So if we wire the curve into the patch, we should see the internal area showing up as red. And that just, yeah.
This is sorry, this is like a really.
No worries.
How come when I put in my boxes, it's script instead of symbols as like.
Yeah, so if you go up into display, if you want to make it look like the icons, you can just turn on draw icons up there. And I kind of like this better just because I have a better like visual memory than just a bunch of text boxes.
Whenever you were having someone get over one.
Yeah. Yeah. It's not going to say the word up top. I have another plugin like reading out the name of the component as well. And I think I described that 2 classes ago, maybe. It should be in Discord somewhere. There's like a sunglasses plugin, so you can see both the name and the photo. Yeah, okay, so now that we have this patch, we can use this as the geometry to then do like the inflation kind of for the pavilion. First thing though, with Kangaroo, it usually only ever, and as the goals show as well, it likes points, meshes, and lines. Anything that isn't one of those 3, it can't really use. So we can't use this surface as it is. We need to convert it to something that Kangaroo can use. Just because Kangaroo doesn't have infinite ability to simulate, so if we break it up into a mesh with, say, a discrete number of points, we can simulate those points. So to convert from a B-rep, which in this case a surface B-reps, very similar things, to a mesh, we can use a component aptly named mesh B-rep, and that'll do the conversion to a mesh for us.
Okay.
Yep. Does anyone know what BREP stands for?
No.
Yeah, so Nick Neal and Associates, the ones that made Rhino, I believe invented that. It's boundary representation. It's like a mathematical way to define a boundary in 2D or 3D. So that kind of helps with the data types that Kangaroo can use as well, just because the surface here is a mathematical representation of the surface. It's nothing physical, but once we convert it to a mesh, now we have something physical that we can simulate the vertices of. So yeah, the next thing we'll do is looking forward to when we do the simulation. I had some points locked in space that couldn't move, kind of giving it the anchor that it all inflated off of. In order to do that, the easiest way would be just to divide the curve into a set number of points. We might have done this before, but pretty common one whenever you want points on a line is we have all these division techniques. The most simplest one is just divide curve. And it should be this line with 4 points on it. This one, if I haven't covered it already, it takes a curve and then a number of points or segments to create out of that curve. So we can start by plugging in the curve, and then we'll immediately get 10 points on that curve. I think 10, yeah.
Where are those 2 dots at the top?
I think that is parallel computing. So not a lot of components have it, but it is interesting. Yeah, you point that out. I believe it's just a more efficient way for this component to run if you're doing a lot of things at once. Like if we were trying to find the points on 10 different curves at once.
Wait, RJ, you
Yeah.
were saying, I had a question. Is it normal that if you're gonna do the B rep, that you would do the patch beforehand? Do those usually go together?
You mean the mesh B-rep
Yeah.
one? Is the question like when
Like-
you would use this?
Like, it's sort of a weird question.
Yeah.
Like, would you make it so that you would, whenever you're doing the mesh, that you also use the patch beforehand?
Not always.
Okay.
The patch really is just good for what I'm doing here. I don't really use it for anything else, but if you want to fill in a 2D curve, you can patch that.
Okay.
But I stress only for 2D. It doesn't work if the curve is 3D somehow. But the mesh, this one I use a lot.
Yeah.
Like there's a lot of things that are B-reps in Grasshopper.
Mhm.
Like if you use any of the primitive spheres or rectangles, like
Okay.
these are also B-reps, so we could
So
convert
it's any
these.
sort of shape or something like that.
Yeah, pretty much anything from like this tab, so the surfaces, like all of these, like a lot of these primitives are just B-reps and they're not actual mesh. So you can kind of see when we convert it to a mesh, it now has these discrete lines and vertices making it up. But the sphere itself, the only thing that defines it
Like that.
is going to be the center point and then the radius. And we can see this kind of curve, this green curve going around,
Yeah.
which that's the only thing defining the shape. So we don't have vertices, there's no faces, vertices, or edges to it. But once you convert it to a mesh, now we actually have geometry. Like, I don't know, you couldn't hold the B-rep because it's not physical. The mesh is. So like also whenever you export, if you go to like 3D print, even in Rhino, like if I was to make a box and then export this to print, it's going to ask me when I export what kind of like polygon size I want to set. Okay, it'll do it for a sphere because rectangle is pretty easy to figure out what you want. Let me try it again.
But it asks you for more information. Sort of like.
Yeah. So, and this is something that people run into sometimes too when they go to export to 3D print. Oh, it's because I didn't save it as an STL. But okay. Now it's going to ask me for like the mesh export options. So it'll automatically convert it to the mesh for you. And then that's like something physical that you can print and hold type of thing. Yeah.
Yeah.
But B-reps are pretty much just math. So.
There's like a new one to be rep without it being natural.
Yeah, so there's a lot of things that only want surfaces. Like when we were doing a workflow a couple weeks ago with that surface texture workflow. Let me find that plugin again. It's called Lunchbox. There's a good meme in the Discord about that one. Like when we were using these components, this one wants a surface to parameterize. The reason being that it likes that math because we're doing a UV setting to it. The mesh doesn't have any of that sort of data. It's just like, okay, there's 1,000 triangles. That's it. But the B-rep does win in that sense because it is made up of a mathematical like equation. So for sometimes it's really good in Grasshopper to know what data type you need and then figure out how to convert to that. So in this sense, we need a mesh for Kangaroo so we can convert. And there's ways to convert from a mesh back to a B-rep, but that's a whole lecture in itself, so not something we go over. Does that make sense for all the questions? Cool. Let me find my space again. Okay, so back to this shape. 10 points might be cool, but you might want more. So you probably know what to do at this point for adding numbers. Yeah, we'll use a slider. You can do anything for this one. It's not going to matter too much. Yeah, so with the slider and the divide component, now we can like say, these are the points that we want to keep on this curve. We don't want them to move at all. And we can define that in the goals. How many people have Rhino 7 in here?
I don't know.
Okay. Yeah, it doesn't really matter too much for this. Rhino 7, though, the one thing I do like about it is it has this quad remesh component that we can use to convert triangular meshes to quads. It just gives a slightly cleaner output. But I think I might skip over to that because I know not everyone has Rhino 7 with the quad remesh. It'll still work as triangles. There's not much of a difference. Yeah, so I'll show real quick like what the difference is. So with this mesh currently, this is what it looks like. So it's mostly quad faces, but we do have a lot of triangles around the edge as they connect back to the curve. If you wanted to use quad remesh, there's two things to do for it. First one is to get the quad remesh component, which this will do the remeshing and convert all of this to squares. The other thing is you'll need quad remesh settings. And this is going to be like a whole way to set up how you want the remesh to look. Because the quad remesh component does ask for settings.
You said only 9/7.
Yeah, I believe so.
Yeah.
But yeah, if you wanted to do it, this would be all you'd have to do to convert. And I'll show like what it looks like when it's converted. So the main thing here is like the target count. So the number of quads that you want to convert to. Currently, if we hover over the mesh, we have 553 faces. So 1,000 is a lot more. Can probably just constrain that to 500. And then when we plug the mesh, the quad remesh will remesh a mesh. So you'll need to plug a mesh in, a lot of that. But now we can see compared to the last one, the topology is just a little bit cleaner. Everything is now a square. So that makes it nice. So just in the case of when we simulate it, the quad remesh option might be a little bit smoother, whereas the other one, since we have like these triangles, they're like the sizes of the polygons are all over the place. Like the triangle down here is a lot smaller than this triangle. So when we move this mesh, it's going to be lumpy in other places, but it'll still work. It's not going to be an issue. It's just if you, what was that?
I'm sorry. I forgot that little yellow.
Yep. Yep. 2 dashes. So yeah, I'll continue with the triangulated mesh. It's not going to make a difference, but if you wanted a slightly cleaner result, you could spend 1.6 seconds to convert. I'll leave that there. Okay, and again, we don't need any of that technically for this. Okay, so that's pretty much all we have to do to set it up, is get a mesh and get the points that we want to lock to the surface. So now we can look at the Kangaroo stuff. So in Kangaroo, the first thing that I usually always do is figure out what solver I want. In this case, we'll use the bouncy one just because the momentum is more fun. So, a question? Yeah, so most of the work here is just going to be like, what do we want our goals to be? There's a lot of options for different goals, but it's up to you to pick the ones that fit best for your situation. In this sense, since we have a mesh and we want to apply some forces to it, some gravity, we do have this mesh tab that has a lot of mesh options in it. And we have this component called vertex loads, and this will take every single vertex of that mesh. So every point where the lines meet is a vertex, and it'll apply a force to that. All of them interact with all of their neighbors, so it's a complex situation. That's why I have a plugin doing it to figure all that out. So vertex loads is going to be the first one. This will apply forces to everything. But if we just apply forces to every single point, actually, this might be fun. Okay, we'll break it before we actually do the correct thing. So for cleanliness sake of all of these goals together, I've used this component called merge before, but we don't want to use it today, but just to show the difference. Merge is something that we can use to put multiple streams together into one output, but it doesn't really respect the way you plug things in too much. So we want to make sure that is more figured out. So there's another component called entwine, which we do want this one. This one kind of respects the order a little bit better. It'll keep everything on its own layer. If you remember back to when we were talking about data structures and like different branches on a tree, we can like plug data into branch 0, branch 1, branch 2, which is nice. We'll only be using the top two, so 0 and 1 at the moment. And for cleanliness sake, we'll plug all of the goals into one. And this will maybe become more obvious in a second, but this is a good way to work so things don't get lost in Kangaroo. With that plugged into entwine, we can just plug all of this into the goal objects. And this will be what Kangaroo uses to do the simulation. I've left 0, 0 open because we have this really nice component called show in the same tab that all of the solvers were in. The reason why I'm using entwine and putting it on two separate branches is because show will take our geometry all the way through till the end. But you have to think about the simulation is only simulating the vertices. So we'll move all the vertices, but the vertices will not be a mesh at the end. We want that final mesh. So this show component will allow us to input the mesh that we want and carry that through to the end. So even though we're simulating the points, the mesh will follow along with it, if that makes sense. So we'll be using the mesh for that. So that'll be what we want to show. So we can plug the mesh into show, and then we'll use 0, 0 as the branch that we want this mesh to be on. Okay, so a few more clean things to do while working with Kangaroo is coming out everything, like all the geometry that we want is going to be coming out of this output letter right there. So the bottom output. But if we look at it, when we start simulating, it's going to output everything. So it's going to output all of the points, all of the lines, the mesh that's in show. And we don't want to see everything. We just want to see that mesh. So we set it up in a way that the mesh we know is going to be on branch 0, 0. So in the output, we can split off the data that we want from the data that we don't want. Like we don't need all the simulation results. We just need the final thing. So the complementary component to entwine would probably be explode tree. So explode tree, and it looks like, I don't know, a tree with a firework on top. Yeah, very literal icon. But this one will do the opposite of our entwine. It'll take a single stream and it'll output the different branches we had. So it'll output 0, 0 and it'll output 0, 1 on different routes. And then we can just take what is on 0, which will be our mesh. One way I like to work when I'm cleaning up a script or organizing different things is if, say, I have this component that has multiple outputs, but I only want to be seeing one of them. What I like to do is just use this, like, data block as just a null placeholder for things. You can put anything in this data block, which I like because I just use it very generically for anything. And we can string up 0, 0 into that data block. So now if we hover over the data block, we just have the mesh coming out, which it's a lot of steps, but this will keep the whole workflow very clean on the back end. Okay, so I'm going to preview off everything that is in that data block because I don't want to be seeing everything that's going on. I just want to see this final mesh. So I might turn off all of this as well. Okay, so the divide and all the points in it.
Yeah.
You could keep that on and turn it off. It won't matter too much, yeah. Okay, so if that's making sense. Before we start simulating, there's a couple other inputs on this solver. The ones to mainly worry about are going to be reset and then this on or off switch. So when we do the simulation, we'll get a thing, but if we want to go back to the start, we can hit the reset button. Yeah, question.
You turn everything to preview off except for the data?
Yep.
Okay.
Yeah. Yeah, so the reset button's nice so we can go back to the beginning, and then on or off is going to be nice so we can start or stop the simulation where we want. So for reset and the on, we'll use two different components, but they're still kind of similar. For the reset, we can use a button. So this is not like a set state. We can hit the button and it'll send a command to reset, but then it'll go back to how buttons work, basically. It'll do that. The other one, so on is going to be different. We could use a button, but that will mean only when we're pressing it is the simulation going to run, and we want to leave it running for a long time. So we can use a Boolean toggle for this. So Boolean toggle, this will set, we can save the state and set, say Now it's on, it'll stay on like a light switch, basically.
How come you don't want to do that for the reset?
Yeah, you could use a toggle for reset. It's just when reset is true, it'll always be resetting. So we could do a toggle, but then it would be a one extra button click to use a toggle, which is not an issue. I just like doing less work. So yeah, the button's nice. You hit it, it'll reset, and then it'll be like, okay, you can go again type thing. So the button will go into reset, the toggle can go to on. And then you can see the state at the bottom of the bouncy solver will change. Now it says pause, so it's not running anymore. But if we were to turn it to true, it would start running things. Okay, so now the solvers should be all set up and it'll start doing things once we start actually defining these goals. The first thing is this vertex loads. So we've been looking at this for a while, but the main thing with any of these goals is it does have this strength input. This one might come into play. It might not for most of them. But first thing we can do, the mesh, self-explanatory, we'll plug the mesh into mesh. And now there's no more errors with the script. Okay, so at this point, it's also good practice to reset every time you update something in the script. So if you add a new mesh, just hit the reset button so it can be back at the beginning again, even if you didn't do anything. Okay, I'm gonna zoom out a little bit. Okay, if we turn it to true now, it should fall out of the scene, which is fun. But that's not what we want. We want it to like make a pavilion. Is it disappearing at all, or it just?
Mine's not. Mine's switching to true.
Oh, so double click on. No, there you go. That's falling through. Yeah, that's.
Oh.
Oh, okay, so we'll just use one of the. Yeah. Yep, that's right.
Oh, there.
Yep.
Thank you.
Okay, so now I've confined my mesh to the bottom of Rhino. But we don't want that. We want it to make a pavilion thing. So we'll have to define a couple more things. Would anyone want to take a guess at what another maybe goal would be to keep it locked there? Yeah, so we have the points, we've set those up. Now we just want to say, don't move. Just like we had a drop down for mesh, we have a drop down for points, and we have some point things here. There's a lot going on, but the one we want to look at is anchor. It's the most basic one. It'll just say, keep these points locked to that position. So I'll grab that, pull that in. I believe, yeah, you can set a time limit, and then like after a certain amount of time, it'll take all the points that are plugged in and just like, I don't know, make them go other places. So I've never found a good use for it in like building things, but might be cool for something. You're welcome to play. You could plug it in as a goal and see what happens with everything else. I don't know, might be interesting. Okay, so we have the anchor, and now we just have to say we want these points to be at that position. Real quick, I'm going to look at these mesh edges again in relation to our points. And you don't need to do any of this, but just to visualize. Okay, so we have these points, and we can see they're lit up in green here. This point, all of the points really are not actually a point on the mesh. We can see with the mesh edges where the vertices would be at the end of all these line segments. And we want to say we want one of those to stay stuck to the ground. Right now, we just have arbitrary points that don't relate to the mesh at all. They're just points on the curve. So we want to relate that back to this mesh. In Kangaroo, usually it's good to think about, okay, we have this mesh and I want to simulate this mesh. If I start plugging in data from other sources, it's going to get really confused. So we want to relate everything back to here. So I'll push this away real quick. So in order to do that, we have a mesh, but we want to find the vertices that we want to stay stuck down. So one way to do that is to deconstruct the mesh. And the deconstruct mesh component when we plug in the mesh to it, will give us everything about it. So the main thing we're looking for is the vertices. So this will show us all of my 506 vertices are now able to be like influenced from this list. So that's a good first step. So now we can actually see the vertices, but now we want to say the points that we found with this divide component. We want to say, we want to point on the mesh that's, relatively close to these points to be the one that's actually stuck down. So we can do that with one other component, and that'll be the closest point. And we've used this one in the past, but basically, again, it'll take a cloud of points, so the points we just found, all of the points from the mesh, and then the input points, so the points from the curve that we divided, and we'll say just find the closest neighbor to that, and then we can use that closest neighbor because it's on the mesh to be our anchor. So with this, we have the points, and we can hover over. We want to start searching from the original points we had, so we can plug those into the points to search from. And then we have the cloud of points, which is every point on the mesh, to do the searching and find the closest neighbor. And now we can see we've taken, let's turn these off. So we've taken the points that we defined with divide and then found the actual point on the mesh that's closest to it with this component. So it didn't change anything too much, which is good. But now we actually have something that's relating back to the original mesh.
All ones closest points be on the line.
They might not be perfectly on the line, just because when we move from brep to mesh, now that we're like discretizing the surface, it's now becoming triangulated. If you zoom in really far, some of the mesh might not fully align to that curve, just because we can't have a mesh with infinite detail to it. Like we can see that little white gap right there.
Physically all.
It might matter of the density of your mesh. If your mesh doesn't have a lot of vertices, it's just finding the closest one. One thing you can do though, for that specific issue is you can use, so in this mesh tab in Grasshopper, we can see like all of the basic mesh things. You can use this quality setting. And you can see in the brep to mesh, it has that S input. You could put the quality setting in there and that'll give you just a lot more like vertices in the mesh.
I just turned on my point count.
Yeah.
And,
Okay. But yeah, the workflow is still going to work as long as you have some points anchored down. But you could, if you wanted to, refine the mesh more than just what I'm basically doing. Okay, so at this point, we do have the points on the mesh that we want to be anchored. So we can wire those in to the anchor point. And that's all we have to do to set up that anchor. I'm just going to hide these again. I don't want to see it. And then at this point, this new goal that we just defined, we need to plug it in to the solver so it knows to use it. We'll want to plug all of the goals also into 0, 1. And the way to do that, if you've forgotten, is we can grab the wire and with holding shift on the keyboard, we can plug multiple wires into one input.
my wires are drive.
Um,
Going into the ender.
Interesting. Yeah, so somehow graphic, which is not
Gonna work too well. Hover over the key output on that first point. Yeah. Oh, okay, so you're using the plural version of the component? So closest points with an S? But if you use the closest point without an S component, they do look very similar. But it should. Yeah. Yeah.
Yeah, that other one, which might have also been the previous issue you had, was it was finding 3 of its closest neighbors, not just 1. But yeah, just different uses for very similar components. Okay, at this point, we can reset the simulation again. and we can go ahead and play it and see what happens. And now the points are stuck, but everything else is still falling. Yeah, cool.
I go so fast.
Yeah, your computer's probably just faster than mine, or maybe doing a simpler mesh. But there is ways to slow it down. You could do like less iterations per pass, because by default it's at 10. That might slow it down a little bit. Yeah. Let me come over. Yeah, you can also in the bouncy solver, since we have momentum, you can also like slow down the damping. So every iteration it will move less and less. You can like kind of lose energy over time. Let's see. So we have the anchor in, but we lost the gravity. So yeah, the vertex loads. So just hold shift. Yeah. Yeah. And now both should be fine, so it should stay. Yeah. Yeah. Okay, yeah, so we have the vertex.
Yeah,
we can plug the anchor into your wire. So you hold
It's
shift.
yeah, I don't.
Mine's like hard.
Try it now. Move to it.
Yeah.
Yeah.
Oh, what?
It's just. It keeps going.
Mine just doesn't have a.
What is it?
Is it supposed to have a lot of lines? Or is it okay that mine just doesn't have any ties to like a bird? Maybe I should know.
Is there a stopping point in this? I mean, this one was.
No, is that not? I don't know. I'll just continue.
Oh, I see now, like the dog is
Okay.
like really far.
It's like, it's going like, I don't.
Yeah, check your closest point. Yeah, okay, so you just plug in and see, which makes sense. But the V will be the vertices that we're searching for. I forget what C is there, but now.
Okay.
Whoa. Oh, no, it should, yeah. Okay. Yeah.
Wow, that's.
Yeah, so we've told it to fall, we've told it to some of the points to stay, but every other point is just seeing fall forever. So the next thing we'll do will solve this issue. So let me go back to Kangaroo. So in the mesh tab, we have this nice one called edge lengths, and this will say, okay, every section of the mesh, every like line that makes it up can only move so much. Right now, we can see a lot of them are moving infinitely far down, which is not good. So we want to restrain them. So it's always good to think about Kangaroo as like you have some components that are affecting it and other ones that are holding it back from being affected. So the vertex loads, the gravity is going to be pulling it, but the edge lengths are going to say you can only pull so far. So it's always like a between like tension and the word that's not tension. I don't know. But yeah, think about like both things. Because if you only have an action and nothing to stop it, it's just going to fall forever. Okay, so at this point, again, it has a mesh input. So we're going to use this mesh component a lot. So we can plug that in. And then we have this length factor, which is a new input here. By default, it's 1. So this is like a multiplication factor. So every line will stay its initial length. So same thing, we'll hold shift and plug this one also into O1. So now I'll reset and now I'll hit true. And now it can only fall so far.
I just jumped to it.
Nice.
Oh. Mine's upside down. Oh, mine is kind of upside down, is that okay?
Yeah.
Okay.
Yeah, it's still falling, but the lines can't move that far, so it's not going to fall too far. So now we've restrained all the lines to only be able to move a little bit. The next thing we'll do though is actually computers are cool. We can say gravity should now be up, and we'll just flip gravity, and that'll fix it. So in the vertex loads, we can see the strength right now is negative 0.1. So that's saying like fall down by 0.1 every iteration. We can just change that with a panel. Again, like 2 forward slashes. And we can just type in positive 0.1. And now we can just flip gravity in the scene. And yeah, now it goes up. And I got this one weird bit. I don't know if I like that, but. So we can use a panel, but it's also might be fun to do a slider.
Yes.
And then we can like say, now it's up, now it's down. And kind of just play with gravity on the fly while the simulation is running. Yeah, it'll just try to pull it up more and more.
Can it just be like 0 to 1 or what should it look like?
You can do any gravity setting you want. The more gravity you do, like in a positive direction, the more it's going to try to pull these edges apart. So it's like fighting between it wants to go up a lot, but also the edge lengths want to stay small. So yeah.
It'll make like the supports smaller, like thinner.
Yeah, it'll kind of stretch everything out. So it's up to you what number you want to use for gravity here.
Wow.
We were familiar about having the line, so I need to be able to see it out. We're gonna have like weird like dates on that.
Yeah. Yeah, with my triangular mesh, it was just a little bit more messy than the fully quad mesh one. The theory behind the Kangaroo is still the same. It's just like the final output with quads is going to be a little bit nicer. Just because everything's a little bit more like homogeneous in terms of size between the sections.
How do you make everything more than just like 0 or 1?
Oh, in the slider. You could, if you right click on it, you can come to edit and we have this like whole panel of stuff we can do to it. The first one, like if you want decimal places, you can set it to be a real, like a floating point number with the R button, and then you can set like the amount of decimal places you want. And then you can also come to min and max and say if you wanted to go like 10, you set the max to 10, and then you have that slider capability. Yeah. Yeah, so that's kind of the first workflow for the pavilion. You'll see after a while it'll say converge and it'll stop moving. Or you can turn it to false and it'll also stop.
For some reason, my mesh is only going down and not up, even when I change the strength.
Interesting. And the strength is a positive number?
Yes.
Hmm. Do you have Kangaroo 1 by chance? Or do
I
you
have
just
Kangaroo 2.
Okay. That's I don't know. It should go up if it's positive.
Strange.
Let me see what else we have. Because we could also do like a force on every single vertice. And then you can set a vector for movement, which will, I think, be the same thing, but just slightly different. Let me try this. Point goes up. Okay. Yeah, this instead of doing vertex loads, you might try the load component. So in the point goal tab, and then we can set a vector for the point movement. So it's a little more controllable than just gravity. And then maybe I can make it go sideways as well. No, that's too much. But yeah, try that. Let me know if that
I will
works.
try.
Okay.
Okay.
And then before we move on to the second, I just want to throw this bomb one in and try that.
I need to know how they're gonna work.
Let me stop this. Mainly, if you hover over any of the inputs or outputs, it's gonna kind of tell you what it wants. Like this one, I read it. I've never used the bomb before, but it said connect this to the same reset input as the solver. So enough to be like, okay, got to plug that button into there, and then it worked. Luckily, some of the times that doesn't happen though. I don't know what's happening, but most of the time you can be like, okay, we need the center of the explosion. So I averaged all the points to a single point, so that's the center, and then the points to be affected. So I'll find the points from the mesh, wire it together. Sometimes that works. But yeah, it explodes a little bit. I don't know. It's kind of fun. Yeah. And then it evens back out.
Could this be used for like simulations or like testing of architectures? So, like, for instance, for that, if you were testing like seismic activity, like.
Yeah. Like MEP or like, is that a word?
Is that like the scale?
Yeah, like I understand what you're talking about. You probably could in Grasshopper or in Kangaroo. You could probably wire it up in a way where you could sim it. But there's also other plugins that do like more of that material testing. Questions?
Oh, I guess it's like, I think one of my points is kind of weird where.
Yeah.
Where, I'm not sure what I did.
Oh yeah. It might just be the way the mesh was made. You could try to like, you could change, yeah, like how many points there are and then reset this. Yeah, when you change this, you have to reset because we're changing the inputs.
Okay,
Yeah.
so like the actual.
Yeah, so anytime you change like anything coming in, you can change the goals all you want and it'll update, but if you say you change the input mesh, you can change the input points. You just have to hit the reset button and then it'll find the viewpoint and start. But it could also just be that your mesh has like one really tiny triangle.
Okay.
It's like, yeah. There's a lot of ways to clean up things in Grasshopper, but if you have questions, we can look at it, but it's more of a boring workflow of like a script that's this long just to clean a mesh. But I do it a lot. So okay, so if the pavilion's working for people, that's cool. We'll take a look at the bridge from that architect, and how to like pull fabric in the simulation in real time. So we can kind of have more of control. Instead of just having the points locked, we can now move some of these anchor points, which might be fun. Okay, so to start off this bridge, let's take a look at the image again. No, I don't care. Does anyone want to take a guess at like some of the basic elements of this before they pulled the fabric? Like how many points there are? Huh?
What do you mean?
Just like what would make up like this shape if you were to do it in real life? Yeah, so we have the boundary around it that everything's tied to, so we call it like the anchor where the things would be. We have a rectangular piece of fabric in the middle that we're like stretching. And then we can do as many points as we want, but in this one, it looks like there's maybe 3 anchor points on either side and 2 in the middle. So if we use this picture as reference, we can do something very similar in Grasshopper. So to start off, when I was trying this out, the easiest way I found, so we don't have to do things twice, I'll just move this away, is to start by drawing a line that'll define the length of this rectangle. And then we can just, in Grasshopper, mirror that and make this rectangular surface. So to start, I'm going back to the origin point, and I'm just drawing a line, doesn't matter how long, but straight on one of the axes. I've just got a very basic line there. And it's important, at least for this, that it's around the origin point, because we can just mirror it over to create the second line. So before we get into Grasshopper, we'll also define the position of those anchor points. And in this way, we can do it by hand. So we can like move these anchor points around. In this sense, we can use the single point tool, and we can just drop points next to this line. They could be on top of the line, they could be next to them. It's not going to matter too much. We'll use that closest point control again to actually get it in the perfect spot. So with Rhino commands, if I haven't mentioned this before, when you do a command, you can right click to redo that command. So I can just keep right clicking and setting down 3 points on one side, 2 in the middle, and then 3 more over here to get that lined up. So if you can't visualize it yet, then the steps in Grasshopper will actually like make the surface from this. But we're just using this as like the very simple Rhino tools to be able to move this around easier than it would be in Grasshopper with sliders or things. Okay, has everyone gotten to this step in Rhino? Okay, so we'll now instance all of this into Grasshopper. So the first one, just like before, we've got a curve, so we need that curve to come into Grasshopper. And then in this case, we also have 8 points on there. So we can use the point component to put those all into. In this case, since we have multiple things, we can set multiple points. Just that line that I drew was just the single curve for this.
You can just do this like underneath our other.
Yeah. This isn't. It's not going to connect to the pass workflow, but we will use a very similar Kangaroo setup. So we might be duplicating the Kangaroo in a minute, just for this one as well.
This is still just one curve, or?
Yeah, just one curve, just that one line.
The dots,
Yeah, not with the dots. The curve component will only take curves. So you can select the points, but it's not going to use them. We will need a point component to do the points as separate objects. So with the point component, once you get that in, there goes land. Yeah. We'll set multiple points with this one because we have more than one point. So when you hit the button to select multiple points, it'll show up your Rhino scene. And for this, it'll just be easier if we select these from like left to right order. So I'll go ahead and click all those in, and you'll see it'll draw a little blue line as we click all these points. So left to right, right to left, it's not going to matter, but as long as you're doing them in order, it'll make the rest of this just slightly easier. Just point. Yeah. Okay, was everyone over there able to put the points in? Cool. Yeah, just enter. Yeah.
How you connect?
When you do select multiple points in Grasshopper, I can look at it. So with the point, we'll do set multiple. And then once you click on this, it'll pull up Rhino. And then once you start selecting the points, it'll just draw a line in between the points as you select them, just to show you like the order you select them in. But the line is not a real thing. It's just a visual thing for now.
Maybe click off first. Ross.
Is it working?
Was the.
I don't know.
Oh, shoot, they're not now. No. I couldn't order anything. You know, the direct action, so I can do this. Okay. So, I'm at this point. And then. To divide. And then. Set most of it.
Oh, okay, so deselect everything in Rhino, click off, and now in Grasshopper, deselect multiple. If you have anything selected in Rhino, when you hit this, it'll think that everything selected was all you wanted. But now you can go in and do all the points, and then just hit enter once you get all 8.
And you're just like drag and select, like top left, down, the bottom right, would it do it left to right?
I think so, yeah, I think so. Yep, it's good. Yeah, if you do box select, it should go in order of like the way the scene is set up, but not always. But yeah. Okay, cool. Now that we have those all in, we can start creating the surface for like the fabric rectangle.
Is there only one line?
Yeah, just one line. Disregard the thing in the back. That was just from before. Yeah, so just this one. In order to make the rectangular piece of fabric, we can just simply mirror this curve around the axis. By default, it's going to be YZ. So if you also drew your curve following the green line, then it should be set up. Let me know if you didn't draw it on the green line. Yeah, it's easy enough. So with the mirror component, we have G for the geometry to do the mirror operation on. And then the second is going to be the plane. So did you draw it like in the red direction? So to just fix that, it's really easy. We can see the little arrows at the bottom. And as we move around, they turn as well. So this red line is following like the XZ plane. So in Grasshopper, if you double click and just type XZ, we'll get an option for that plane. And then you can just replace the plane input with the XZ plane, and this will fix it. No, by default it's YZ, so you're good. Yeah, but yeah, it should just be 2 curves around the axis. With these, we can merge them together because we can create a loft in between these 2 curves to make that actual surface. So we'll just want to put both of the curves into a merge so we can have them as a single output. It'll always add a third or a fourth or a fifth as you keep adding data. Yeah, I do it by habit, but you can zoom in to merge, and you can, once you zoom in enough, little plus minus signs will come up. And then if you want to, you can add like as many blocks as you want, or take some away. Okay, so now that they're all in a single stream, we can loft the 2 together with a loft component. This one just has a single input for curves, so it's good to set it up that we only have a single output for curves. And you should, plugging those outputs together, just get a green rectangle in between the 2 lines. And this will be the fabric that we'll use as the basis for the sim.
Is it better for it to be thinner and not really on the front?
It won't matter too much. It won't matter too much, yeah. And we can change this later on when we start the sim. You could come back and make that curve longer if you wanted to. Yeah. Okay, so with this, we'll just want to, we set up these points, but we want to actually map them to each of the curves. So we can find those anchor points on both sides. The reason I set it up this way is because I didn't want to draw points again on the other side as well. So we'll just be like mirroring everything. But this one, pretty easy. We use closest point in the last workflow. But with this, we can use curve closest point, and this will find the closest point on a curve. So since we have a curve and points, it just makes sense to use this as the simplest option. This takes inputs for points. We have those as the 8 that we drew, and then it also takes curves. And we have both of the curves coming out of the merge. So that makes it nice. So we want to find the points on the curve. So we can use merge as both of the curves into C. And then we also have the points from the point component that we want to map to the curves. So we can plug those into P. And then now we should get points being pulled onto the curves.
Just on one side?
Right, so you will notice it's only going on one of the curves currently. And this is just a very simple data structure issue. Right now, coming out of merge, we have 2 curves. So first curve, second curve. So that comes in just like that. And we have 8 points. So in this sense, what it's doing right now is it's saying, okay, first point is going to go to the first thing in the second list, which is that first curve. And then second point is going to go to the second thing, which is going to be that second curve. And then it's trying to put the third point on the third curve, but since there is no third curve, it's going to go to the second curve. So yeah, just slight issue with how that's set up. What we can do though, is we can put each of the curves on their own separate list. So it looks at all 8 points for each of the curves. And simplest way to do that is just to right click on the second input here and graph that. And now it'll be putting 8 points on both curves instead of 8 points between the two.
Mine
Yeah.
showing the red box.
Oh,
It's from the loft.
Yes.
I mean, yeah.
so
I just wonder if I did something wrong with the curve.
If you hover over the
put it on the. Oh, yeah, you might need to put it on.
There, there.
Because if it's gonna.
Hover
hurt it,
over the wall. No, put it there. There is a surface there.
Okay, doesn't matter, and I was gonna ask you, doesn't matter that mine is
Within the.
Oh,
Like the path.
Yeah.
Well,
Okay.
Yeah, they'll be separate.
Okay.
So, yeah, everything looks good. Yeah. I think, you know. But are those the original 8 points from the?
Oh, yeah, I just haven't got to it yet. Okay.
Start this from the other side. Yeah, if you graph the curve, it should fix everything. Yep. Yep. Yeah.
For some reason, I don't have the.
Oh, like the red rectangle.
Yeah. Like,
Everything looks. Did we see why? Oh, okay, so the Y is like.
oh, wait, it's literally.
I want to. So, yeah, just look back. Which, actually, I wonder if we have an image over here. What do you have?
Yeah.
Oh, wait, curve, is it drawn on?
Yeah, I was like.
Yes.
Oh, okay, so grab the curve and just pull it one direction and go.
Okay.
Yeah, there you go. Okay.
Thank you.
Yep.
That is great. No, I never watched that. How did my grandmother do it?
Okay.
Class.
Okay, cool. So now that we have all this, we'll have to do the same thing again where we have a surface again, we want to mesh. So mesh brep will solve that. Okay. I'll plug that together. We have a mesh. And then same thing again with, we did the curve closest point, but we're going to be using the mesh and we need the points in relation to the mesh. So we'll need to do the same process again of deconstructing that mesh, finding the vertices, and then finding the closest point on there. So same workflow as before. If you want to copy and paste it, that'll work. I'm just going to set it up again quickly. Just leave that there. Cool.
What is that?
Closest point. Okay, so at this point, we should see now we have the points in a slightly different position, but we're having an issue where it's not on here now. Just like earlier when we had maybe an issue with there not being enough vertices. Let me show the mesh edges again. And you can see this rectangle is not made up of a lot of faces, so there's not a lot of vertices to go around. So back in the mesh tab, we can set up some, okay. Let me see actually if quality will work. I doubt it. Yeah. We can use this component called custom mesh settings to actually give us more faces. Right now we have 20, which is not going to give us a lot of detail in the simulation if we only have a few points to move around. Is it?
No.
Oh, okay. Yeah, custom mesh settings or in the Grasshopper mesh tab in utilities.
It's just called settings.
Yeah.
Parentheses. Let's go.
Yeah. Let me try something real quick. Okay, cool. That's what I thought. Okay, so the main thing here is going to be this minimum number of quads in the face. The larger we go with this, the more detail we'll have in the mesh itself. And you can use this mesh edges component if you want to visualize it, or big number will do better things. So there's that too. Let me see what a good number may be. Yeah, right now at 300, that looks pretty good for detail on a surface.
Wow. That's crazy.
But yeah, don't do too many. But we'll want to put enough that we have like enough vertices to simulate and get something that isn't like really blocky. So
Is there a way to make those square by the,
Like the mesh.
without just guessing the slider.
Yeah, well, the way I had the workflow set out is I was using quad remesh as an
Okay.
important component. But not everyone has 7, so this is a good alternative.
If I can use quad.
Yeah, I did the same, like how I did quad remesh earlier, I did the same thing, and then you can actually like say, I want like 300 faces, and then it'll always do that. But yeah, just to make this one open to whatever Rhino you have, we can use this to actually change the mesh in a different way. So, okay, at this point, we now have everything we need to set up the Kangaroo workflow. So in this one, we're going to be using the exact same Kangaroo setup as we did before, sans the bomb, but everything else we'll track. So I'm going to copy and paste it. Feel free to do the same, because it'd just be annoying to set it up by hand again. So. One tip for Grasshopper, when you copy things, if you just do Control V to paste, it'll paste it in the same spot. Bless you. But if you scroll to somewhere else on the canvas and then do Control Shift V, then it'll paste it where you're looking. So that might be a little helpful instead of it just going over top of everything else.
Well, it's still connected.
Yeah.
Okay, you're still connected.
Yeah, it keeps the connections. We don't really want for this because we want to replace the mesh with the new mesh that we made. One way though to work is, I mentioned this before, but this data component, I like to use it generally for doing anything. In this sense, it can just be a way to like tie stuff together. So we could have, instead of the mesh going straight to everything, we could just have like a data block that we can use this as the conduit for the mesh to kind of clean things up so there's not wires everywhere. Is one way. But yeah, we'll want to remove most of these wires. There's a couple ways to do that. The first one is you can drag a new wire in. Like for this anchor block, we have new points that we want to keep anchored. So from my closest point, I can drag in and it'll replace that wire, which is nice. For other ones though, you can right click on any input, hover over disconnect, and we can see the different wires that we have a choice of disconnecting. And then you can say, you know, I don't want the bomb anymore, so I can just click that to take it out. There's another one in here. What is that? Oh yeah, the load from earlier. I'm gonna get rid of that one too. Don't need that anymore. Yeah, if you right click on any input, it'll have this disconnect 3 buttons down, and it'll give you a little list of all the wires coming into that one input. Yeah, or you could, yeah, disconnect all also works, yeah.
What do you have going into that data?
Just the mesh. Yeah. I'm using it as a like a generic component just to clean wires up, and not have a spaghetti mess.
And you just moved it, or you copied it? So from the.
Yeah, I just copied the Kangaroo that we were doing, so the goals, the entwine, the solver, and just moved it down. Yeah, so the goals should all still be wired up the same way they were before.
Do we need the other like closest point and disconnect to the?
You could duplicate it, or we can just, yeah, it's the same concept as before. We'll just need the points that are on each of the lines. So there's eight points on each line.
Do we need the deconstruct mesh?
Yeah, in order to find the closest point.
We don't, we did that with this, but we don't need it.
No, yeah, we built this one a few minutes ago, so you don't need to copy that over. You just need the Kangaroo. Yeah, and we can replace the wires once you duplicate it. Okay, has everyone got that wired in? Cool. Okay, at this point, the kangaroo will work, but it'll do a pavilion again, which we don't need. So for this, basically what I want to do is in order to get to the shape of this bridge, we could keep the 3 on either side where they are and just kind of pull down those middle 2 to start affecting it. So in order to do that, if we look at this anchor component, it has a second input called target. So a target location to pull the anchors to. So it'll try to pull them to a different location than where they started. We can utilize this to move the points around and then get this this piece of fabric to follow. So we'll set up a little thing to add new points of where we want these to move to. So basically, I'm going to work in the space like between the closest point and the anchor and add some components here to solve this issue.
You go up a little more.
Yeah,
Okay, thank you.
yeah.
I don't know the right. Oh, you did it wrong. Yeah. Are you?
Yeah.
It's not showing my bridge on my bridge. Like it's still just like showing the initial one we did, but it's not showing.
Like the simulation one.
Yeah, it's not showing the. That was on my. On this one.
Yeah.
And then it was.
Is that the previous
This,
one?
yeah, that was the previous one.
Did you reset this? The new simulation? Yeah, to your right. You hit the to your right. Yeah, there's a reset button. Yeah, that button. Hit that one.
Oh.
Yeah.
Oh.
And then it changed the trees.
Okay, okay, thank you.
Yep. Yep.
Looks like a burrito.
Yeah, so we're close.
Okay.
With this one, gravity is not going to matter too much because we're going to do the stretching ourselves with the points. So we could set the gravity just to be 0, kind of neutral. Gravity would kind of influence the structure. We want to just be pulling the mesh. But yeah, still good to have the physics of the load in there. Okay, so to actually move these points, we can use a move component and we'll build up to everything we need for this move. First thing though, with the move, we will be moving the points to new locations. So we can wire those in. You'll see they'll move up, but we want to add in a slider so we can actually control the direction of where they're moving. We will know if we're relating back to this image, we can move the points up and down on that Z axis. We just want to pull those middle 2 straight down. So in order to do that, we could set up our own vector, which a vector is a point and like a distance, like a direction. We could set up our own vector, but since we know we want to just move in the Z axis, just like with the X, Y, Y, Z plane from earlier, we also have, if you just type in X, Y, or Z, you'll get a vector component for that direction. So with the Z vector, we can plug in just a number, and then it'll give us a vector in the Z direction based on that distance. So by default, it's 1. So plug that into the transform and the points, instead of now moving 10, they'll just be moving up by 1. But again, we don't want them all to move. We just want these middle 2 to move. So how do we select out just those 2 to move instead of moving everything? What we can do is right now we have just a single number of 1 coming into this vector of Z. So it's saying for every point, we only have 1 way to move it. So it'll just move everything up by 1. What we could do though, is have a list of 8 movement numbers, set the first 3 to be nothing, the second 2 to be whatever the slider is. and then the last three to stay at 0. Kind of similar to the surface texture workflow we did a few classes ago. One way to do that is we'll keep it parametric. We can use a component called duplicate data. And what this will do is it'll take a piece of data and then duplicate it a certain number of times. And I mentioned I want to keep it parametric, so I'll set it up in a way that you can come back and add more points later. Instead of 8, you could do 10 or so, and this would still function without having to change sliders or things. So we can start off with just neutral movement, which would be a movement of 0. So I'm going to use a panel here. You could also use a slider, but as long as it's 0. And this will be the number that we can duplicate. So if we duplicate 0 7 more times, we'll get 8 values of 0. And then that'll basically move everything nowhere. And then we can come back and select the middle 2 and say, okay, I want to put a number here in this list. You'll see how it's set up in a moment for how this is making sense. But in order to duplicate the number, right now it's just doing it once. We'll want to know how many points we have. We know we set 8, which is fine. But if you went back and changed the number, you don't want to come back and have to say, okay, now I have 10. It'd be nice if it could figure that out for itself. We can use a component called list length for that. What this will do is you can input any list into it, and it'll tell you like how many items are in that list. So this is nice. If we, add 2 more points, this will automatically see that now we have 10 points just by checking the length of that list. So coming out, we have 2 branches, each of them has a count, and it's counting the 8 points. We can use that as the number to duplicate. And now we'll have 2 lists with 8 points of data, each of those data points being 0. So this is kind of our baseline. So things are going to be adding here a little bit. Okay, so at this point, we can come in and say, we know we have 8 points. If we count the indexes, we start at 0. So 0, 1, 2, 3, and 4 are going to be the middle 2. So we know we'll want to replace 3 and 4 with a slider value so we can move this in real time. We can use a component, and we've probably used this before, called replace items. So we can take a whole list. We know which indices we want to replace, and then we can add a value in to replace with that new value. So replace items. It's got 3 inputs that we want to take a look at. The first one being the list to do an operation on, to modify. We know we want to modify this list of all zeros. Coming down 2 input to the indices. This is asking for, at which point do you want to replace data with a slider? So we know if we count, we know 3 and 4 are going to be the ones we want to replace. So I'll use a panel for this for 3 and 4, but there's a special way to create the panel for when you're doing multiple number inputs instead of just 1. But it starts the same. So we'll do the 2 slashes, and we want to do 3 and 4. But to start, I'll just do 2 slashes and then 3, and then hit enter. And this, just like panels before, will give us a panel with 1 number with the number 3 in it. If we double click in the panel, it'll open up a little bit more to a better editor. And we can come down with the enter key to the second line, type in the number 4. And now we have 3 and 4. It gets a little finicky though. If you hit enter again, you think enter would accept it, but it would just make a new line. This line is technically a new piece of data, which is going to throw a spanner in the operation of what we're doing. So 3, 4, nothing else, and you can hit OK. At this point, we have a panel with 3 and 4 in it. But currently, this is not 2 separate pieces of data. It's 1 piece of data that has 3 and then 4 on a second line, which if we know we want to do indice 3 and 4, we'll have to see this as separate as well. So it's a finicky component, but what we can do to actually say 3 and 4 are separate numbers is you can right click and then check this box for multi-line data. Very important here for the panel operation. And this is used quite often too, so it's good to know. It'll now split it and say 3 is on index 0, 4 is on index 1. So cool. we have two separate pieces of data, each on their own index. So we can plug that into I for index. Okay, so now it's all set up. Now we can actually put in the number slider that we can use to move these points up and down. Since I want to pull these points down similar to the drawing, I'm going to make a slider from -10, say, to 0. So we have this whole negative range of movement. Okay, so with this slider, we can add that to the items that we want to replace. So these are the new values that will be replacing the old values. Just to show, you don't have to do this step, but with a panel, I can actually go check my final list. And we can see that this looks pretty good, matches up. The first 3 have no movement. The middle 2 do have some movement. So it's nice.
You might have said this in an earlier class, but
Yep.
all of the lists always start at 0.
Yep. Yeah, I can't think of a way that it would start at a different number.
Well, just start at 1.
Just one.
I mean, you could delete indices and things, but I don't know if it would rewrite it where the first number is always 0, or if you could just delete 0. I'm not exactly sure, but for most cases, you're always going to start counting at 0. Yeah. Okay, so now that we have this whole list of numbers, again, with the z vector, we can use the numbers as the distance for a vector. And now with that all wired in, we can see just these middle 2 points are moving up and down. Cool, so I'm just gonna set mine at 0. You don't have to do that though. Now that we have these points that are now moved to new locations, we can use these as the target in the anchor. So now it's gonna try to take our original points and move them to these new locations. It's important in this list too that the points we start with, so the ones in P, correlate again to the ones in the target. So the first point, so 0.0 in P is going to be pulled to 0.0 in the target, so forth and so forth as you go down the rest of the points. So the order of the points does matter. So we know that the middle 2 will always be pulled to the middle 2 in the target. So everyone got that wired in? Cool. At this point, we can reset the simulation since we changed some of the numbers. We'll have to reset. And now we should be good to set the toggle to true and start the simulation again. So reset, set to true, and then now as I pull these middle 2 points down, yeah, we get this surface now in the middle that is no longer flat. It is now doubly curved, which is good for bridges in this scenario because a doubly curved surface is a lot stronger in the curves than just a flat sheet. So is it looking something like that?
Like going to.
So when you start with simulation, goes away. Oh, okay. Try to set that slider for the gravity to 0. Yeah. Try that. And you just have to hit the reset button. Take out the 0 from the string. So yeah, just leave that one. That's hard to achieve. Nice. Cool.
Archie, can you look at mine?
Yeah.
Looks like doing not that. It looks like it's open.
So it's
You could- Yeah.
It's going down 2 points. Not the.
No.
you see that perspective in the camera? In right.
Oh, Do you think it was because, when I made my line with
Yeah.
the points, I like made it the size of the line? Like I made it.
I don't think the length should matter. I think points to set. I'm counting seven off here.
Oh, I know. I put it
Which isn't an issue, it's, if you put in as many points as you want.
I know.
They're also
but
making points. Let's split with it. Well, they don't show up, so that's, fine. I just,
Okay.
I hover over the error bubble. if that will work.
Yeah.
Oh, someone of my switches got here to do which. But yeah, so if you don't have 8 points, then the index 3 and 4 is gonna be slightly shifted.
Oh, okay.
Uh,
Shoot, I don't know when that's.
Everything else checks out.
Okay.
And
Can
yeah,
I add a new? Wait,
yeah, I
I
think
might
that's,
just read you.
yeah, you could just
Yeah.
do another 8 points.
Okay.
I think since the last one, this one, that right side is falling down there.
Yeah, oh, okay, that makes sense. So it would be working if they had the other one.
Yeah,
Damn it.
everything else is already set up.
That's really stupid. Okay.
Um,
You know better than-
There was probably a way to write this better where it would always select the middle two depending on what the full number was, but I said that's just more components, so.
Turn off the original, like,
Yeah, you can just hide like everything except for that final data block.
Arguing.
Yeah.
Something going wrong.
Yeah.
Yes, so it's still flat. Like,
yeah, so set the vertex movement 0. Yeah. Yeah, and we set the simulation. Okay, yeah, so if you scroll over to the slider right there, oh, so thanks.
is it possible that these dots are not connected to something? Do the meaning?
Everything looks like, not gonna make a mouse.
Yes.
Yeah, it looks to be why, right? Okay, yeah, everything looks fine, so. Cool.
So that's basically it for this one. If you want to get a little fancy with it, and not just have a surface, this is extra, but. Oh, shit. Am I misspelling the word offset? Ah, never mind. Okay, got it. To thicken this up, we could use the offset mesh from pufferfish to give us some thickness on it. And we can use a slider to control that thickness. Which is cool. And then,
that slider to 1.
yeah, I did from 0.1 to 1. Yeah, so if you want to, you could thicken it and then smooth it out with Weaverbird. And then we get more of a nice smooth mesh instead of just that rectangular surface. It's a little bit nicer. Yeah, but a little bit of a stretch goal there for that one. That's pretty cool.
Is there a way to like do the smoothing? and Don't have anything. You can show.
Yeah, there might be other plugins that have it. Weaverbird's just a nice one, and you don't need any of this, like the ending part. Mainly just the Kangaroo process. But yeah, this is one way too to go from like a surface, or a mesh surface in Kangaroo to then something thick you could 3D print if you wanted to.
Wait, what's that? That block? The
I'll
only
just
end?
set the print.
This one?
Is that-
This is Weaver Bird,
These are orders.
is a Catmull Clark subdivision from Weaver Bird.
Do you not have it now?
Oh, I do.
Oh, nice.
There's no way. Watch us read. So put another point and then you use your point.
Oh, I see. I think it's probably good practice.
2 hours have passed. I'll just.
Yeah, got it, but it didn't smooth it out.
I mean.
It should look a little smoother. As long as it's going from the offset mesh. But
That is such a good point. Oh my god, it's
yeah,
fixed.
it's okay.
It's fixed. God bless. Yeah, my head.
I got
God.
It's just got like this semester.
Yeah, I'm like, I figure it would probably be good for me. I don't know. Why?
You do everything else off, so
I don't think it was wrong.
like you do off for that.
That is not meant to be.
Yeah. Oh, yeah, it's long.
I need the auto curtains, right? Oh my god. I got it.
Yeah,
I
yeah.
was deciding between if I really wanted red sauce or if I wanted like white sauce, but I ended up going with white sauce.
One more tip, it is 7, but one more tip to make this maybe look a little bit more like the surface from the photo. Is we haven't really touched on the length factor for edge lengths, but you could make this a lot smaller than 1. And that'll kind of pull all the other parts together more. Let's see. Where it just kind of get a lot more taut as a surface. So there's that if you want to play with that as well, but basically it. So just covering like arches and dome workflows today and how you can simulate those physically in software, which is cool. But yeah, that's it. For next class, if you want to bring in sketches, ideas of a final project, we can talk about those and move more forward with that. But we will be doing another Grasshopper workflow next class after we look at everyone's ideas. So
So if I wanted to print this, let's take it back in Grasshopper.